All right. Trigonometric functions and real numbers. So I'm going to talk about, we did a lesson on Wednesday and Tuesday where we talked about the triangles and the sine and the cosine. We're going to do that again. So let's look at this reference triangle. If I don't know the degree measure, I call that theta, right? Notice how my triangle always has an x-axis side. Even if I'll show you down below, I can do my triangle in any quadrant, but there has to be an x-axis. So along this side is my x, right? Going left and right along the x-axis. When I go up and down, that's y, up and down. My radius is always 1. So the whole idea of cosine, which is adjacent over hypotenuse, cosine, adjacent over hypotenuse, x over 1. That's why cosine is x. That's why cosine is x over 1, x. Sine is opposite over hypotenuse. Sine is y opposite over 1, y over 1. Y over 1 is y, which is why my sine of any angle is my y over 1 in this triangle example. We're going to use numbers later. Tangent is opposite over adjacent, which is opposite y over adjacent x, y over x, y over x. Of course, you remember that cosecant is the reciprocal of sine 1 over y. Cosine has a reciprocal, which is called secant, 1 over x. Tangent has a reciprocal, which is cotangent, x over y. So these are all there. You don't need to write anything, you're just watching. Next, I'm just going to go down to here. And here's where I'm going to show you that triangles can be in all sorts of quadrants. If I were to draw this triangle and I'd say, hey, this looks like it's at, I don't know, 315 degrees. When I make my triangle, I look at the reference angle. The reference angle is how far is it from the x-axis? That means that this one's going to be 45 degrees. How about if I made a triangle over here and I said, hey, this is going to be about, I'll just make it up, 150 degrees. Here's a 150 degree angle right here, 150 degrees. But I do not make a triangle on the y-axis. No, 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 no. I reference angle, always use my x-axis. And so this is then 30-degree triangle is made from a 150-degree angle. You get that? I was told to make a 150-degree angle, but when I draw the triangle to start labeling things, sine, cosine, tangent, it's a 30 degrees reference angle. That's what I'm looking at. Okay? If I have a triangle that's in quadrant 3, and it's like 210 degrees, 90, 180, 210. Well, doesn't this 210 degree, if I make a triangle, this reference angle is 180 plus 30, right? This is a 30-degree triangle then that I'm focusing on. So the way that I make triangles for our future examples is I need to make sure the x-axis is part of the triangle. The x-axis needs to be part of the triangle. So now let's look at this. I'm going to tell you that the radius is r, okay? X, y, and r. Usually it's 1, but sometimes I might give you a value, like a 3, 4, 5 triangle, right? Obviously, sine is going to be opposite over hypotenuse, y over r. It's reciprocal, r over y, whatever the radius is. Cosine, adjacent over hypotenuse, x over the radius. Reciprocal, r over x. Tangent, opposite over adjacent, y over x. Cotangent, x over y. This is basically the same thing I said up above. I just repeated myself and I didn't use a 1 for my radius, I used an r. All right, I'm going to go down to example 1 now. I'm going to do the odds and your evens are homework. 2, 4, 6. Your homework is 2, 4, 6 in notes, in case you want to write it down now. Your homework is 2, 4, 6. Just that's it. 2, 4, and 6. All right. Evaluate all 6 trig ratios of a 30-degree angle. Okay. I have to draw a 30-degree angle, just like a basic one. It doesn't matter where it is. Let's say this will be in like quadrant 1, right? This would be in quadrant 1. What was it that I said was opposite when I have a hypotenuse of 1? What number is opposite 30 degrees? Remember that day when I did the 6 triangles and you had to draw them all out? I just showed you the paper on the screen on the
1/2.
1/2, good job. That means that opposite 60 is rad 3 over 2. Does this ring a bell? Okay. All the 6 trig functions mean is sine, cosine, tangent, cosecant, secant, tangent, and then their inverses match up, right? Sine means I want you to tell me what's opposite over adjacent, what's opposite over hypotenuse for the 30-degree angle. Cosecant of 30, secant of 30, cotangent of 30. Here are my 6. Sine of 30 degrees. Opposite over hypotenuse. 1/2 divided by 1. Cosine, adjacent over hypotenuse. Rad 3 over 2 divided by 1. Tangent of 30. Opposite over adjacent. Woo! Hold up. Opposite over adjacent. Oh. Fraction over a fraction. The denominator can't have a fraction in it. I need to simplify the denominator by what?
Multiplying the radicals on both the denominator and the numerator. Radical 3, right?
Okay. That would be if it weren't so complex and I only had like one radical in the denominator, but I have a fraction and a radical in the denominator. So to cancel out this denominator so that it doesn't appear, because I don't want a denominator with a fraction, you're reciprocal. Because see how now, hold on. See how now my rad 3's cancel, my 2's cancel, my denominator is gone. Whatever I do to the bottom, I do to the top. So now I have a 2 over 2 rad 3. Well, simplify that. 1 over rad 3. Now I can do your method, Hannah. It's called rationalizing the denominator. Multiply by the radical denominator to cancel it out. The numerator says rad 3, the denominator says square root of 9, which is 3. I'll move in 1 second. There you go. Cosecant. I'm out of space. Cosecant of 30. It's the reciprocal of 1/2. Secant of 30. It's the reciprocal of the cosine. 2 over rad 3. Oh, I have a rad 3 in the denominator. Rationalize the denominator. There I go. There's secant.
What was cosecant?
It's this line right here. Just positive 2, because the 1/2 reciprocal is 2. Cotangent, reciprocal of tangent. The 3's on the numerator, the rad 3's on the denominator. Oh, work it out, work it out. 3 rad 3 over 3. Simplify. Just radical 3. You're doing example 2 for homework, remember? But I just want to bring up that your 120-degree angle is going to be 90 plus 30 more. So it's like, I don't know, like there, right? But when you draw your triangle has to be an x-axis side. So here's my triangle. That means that the focus angle, my reference angle, is 60. I do a triangle with 60 here, 30's up here, and then you label it accordingly. You have to do that on your own. But I suggest that you copy example 2, like right now. Because I'm scrolling down. Number 2 is your homework, number 4 is your homework, number 6 is your homework. I'm gonna go to number 3. Okay. I'm now given a value, 4/5. Well, we know that a 4 over 5 really stands for cosine adjacent over hypotenuse. Number 3, adjacent is -4, hypotenuse is 5. So I'm going to draw a triangle that has where? Oh, in quadrant 2. Okay. I don't know the angle size, so it's theta, right? Cosine theta, theta. But I know this is in quadrant 2. Adjacent to this angle is a -4. That's my x, yeah? The hypotenuse of this triangle is not 1, it's 5. Remember, my triangle has to have x-axis. Obviously it's a right triangle, but what's the missing side? If you do Pythagorean theorem in your head, blank 4, 5. Someone new, not Rena, not Hannah. Blank 4, 5. Oh, come on. Did you guys take geometry last year? Oh yeah, you did because you're in algebra 2 now. Blank 4, 5.
X equals 3.
Thank you. The missing side is 3. The only reason this is a -4 is because it's moving to the left, right? 4 spaces to the left. So here we go. I have to find sine theta and tangent of theta. They told me cosine. Sine, opposite over hypotenuse. Opposite over hypotenuse. Here's the angle. It's always the central angle, the center. Opposite is 3, hypotenuse is 5. Tangent. Opposite over adjacent. Opposite over adjacent. 3 over -4. So this time I was given values. I had to make my own triangle and label it with the 4 and the 5. You have to do example 4 for homework. Tan means opposite over adjacent, and this is in quadrant 4. Pay attention to that. You're drawing your triangle in quadrant 4. So you're doing number 4 for homework. Now I'm going to do 6. Or actually, I'm going to do 5. You're going to do 6 for homework. I'm going to do 5. I wrote this out to help you. Here's some Pythagorean triples. 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17. Just, you know. Good to know. Good to have memorized in the back of your brain. Okay. What? 7 pi over 6? What's that? Look on your unit circle. Tell me what it is. How many degrees?
210.
210 degrees. Awesome. So first I need to draw the angle. Then I need to draw the triangle. Draw and label the triangle. Okay. Dun, 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 dun. 210 degrees. It's going to be where it is. It is in quadrant 3, is it not? Because it's past 180. 210. Ready? 90, 180, 210. This is 180 plus 30 degrees. My reference angle is 30 degrees. That's the degrees that's off the central angle. So when I draw this triangle, I know that it's this dark x-axis and the 30 degrees. So this is 210, right? So I have properly labeled my 210 degrees, which is now a 30, 60, 90 triangle in quadrant 3. What does it say to do? Find all 6 trig ratios of this 30. 30, we know the 30 stuff. Opposite 30 degrees is 1/2. Since it's in quadrant 3, it's a -1/2 because I go down, right? Opposite the 60 degrees is rad 3 over 2. And I know that that's negative because it's going left to make the triangle, right? Correct? I'm not going to say the word right. I'm going to say correct. The signage matters. All right. Sine of 7 pi over 6, which is 210 degrees. Cosine of 7 pi over 6. Tangent. Oh, I got to move. Whenever I'm writing in my shadow, then you can't see. That's not good. Cosecant, secant, cotangent. Okay. I'm looking at this triangle. I know that they've got like a 1/2 in it, a rad 3 over 2, and a 1. So I'm going to now label opposite over hypotenuse for sine. Okay, sine is also my y value, so -1/2. Opposite over hypotenuse, -1/2, my y value, yx. I'm not going to put over 1. Nobody does 1/2 over 1. But since it's in quadrant 3, it's a negative. My cosine is also my x value, right? Which is -rad3 over 2. Tangent is y over x, which is, ready? Woo! Okay. -1/2 over -rad3 over 2. You're like, no, Mrs. Grant, no. Yes, yes. Times. Obviously, a negative divided by a negative is going to be a positive. But anyways, do you want me to just do it for you? We have such limited time. We really do. Anyways, you work it out. You rationalize the denominator. Negative times negative is a positive. The answer is rad3 over 3. Then, the next thing I'm going to do is cosecant and secant. So they're just like switched, right? If I have -1/2 as my original for sine, its reciprocal is -2. Cosine of this triangle is -rad3 over 2. Its reciprocal is -2 divided by rad3, which is like, rationalize the denominator. -2 rad3 over 3. My cotangent is tangent reciprocal. 3 on the numerator, rad3 on the denominator. Sorry, I keep switching colors. I try to be. Rationalize the denominator. Uh, 3 rad3 on the numerator over radical 9. Radical 9 reduces to 3. Simplify that out, it's just radical 3. So this problem, like 5 and 6, you have to do the 6 parts to it, so it makes it a little longer. On example 6, what you're doing for homework, you need to find 5 pi over 3. Okay? So that means that you actually need to do like, it's not on your unit circle, guys. Well, yeah, it is, because it's 300, but if you wanted to like do this, you could do this to convert, right? Draw 300, it's in quadrant 4. Right? Remember, your triangle has to have the x-axis as one of the sides. Right, I'm going to stop the recording.